Hello student, welcome back to the channel Kunal sir at JEE NEET Chemistry World. As the JEE Mains exam is going on, so I also take few initiative to explain the question answer which is coming into the ongoing JEE Mains exam in April sessions. Today I am going to discuss the first day, that means 2nd April morning shift some question answers. So in the chemistry, this is whatever questions we got from memory based, only that questions I am going to discuss. Now one of the question in chemistry came, which of the following molecules hydrolyze fast? Hydrolysis means reaction with the water. Water will, and as all compound are carbonyl compound, you know very well, because carbon oxygen double bond is there. So now hydrolysis means it will be attacked by water molecule oxygen as a lone pair, it will act as a nucleophile, and carbonyl carbon is a electrophilic center. Why? Because carbonyl carbon is connected to the double bonded oxygen. Oxygen is highly electronegative. It will withdraw the bonded electron pair towards itself. Because of that, carbonyl carbon will be electrophilic in nature. Nucleophile is always searching for electrophile. Electron loving substance is electrophile. Nucleus loving substance is a nucleophile. Nucleophile is a electron efficient. Electrophile is a electron deficient. So that's why nucleophile is searching the electrophile. So now, in general idea, if you look at that question number 1 as here, the option A is there, acid chloride. So acid chloride means what is there, my dear? You have a CH3COCl. Hydrolysis means you know very well, water molecule will attack over here. And now this will go over here. Now whenever these things is happening and this CH3CO minus, here OH2 plus, and this is your Cl. When these negative charge is backfiring, Cl minus is departing. Why? Because chlorine is a very good living group. So that's why you are getting CH3CO from OH2 plus, also proton loss, so that it is forming OH, and H plus and Cl minus is forming HCl. Now the question is, this Cl minus exert the minus I effect, electron withdrawing via inductive effect. Because of that, the electrophilic character of carbonyl carbon, which will be more. And because of that, what is going to happen? Because of that, this H2 is attacking the carbonyl carbon very easily, so that the Cl minus can depart quickly. Now what about the B? Now B, if you look at the B, in B what is going to happen? B they are giving, if you look at the B what they are giving? In the B they are giving like that CH3CO NH2 they are giving. Now this CH3CO NH2 is a acidamide. But this acidamide is electrophilic character of carbonyl carbon is very less. Why? Because here the situation is like this, CH3CO NH2. Now the situation is this lone pair of nitrogen is in conjugation with a CO. So that's why it is giving a plus R to the carbonyl carbon. That's why you can see very clearly this carbonyl carbon positive charge is less, but negative charge is increasing in this carbonyl carbon. That's why nucleophilic attack is getting hindered. Whereas if you look at the ester, option C, they are giving ester. Ester also what is there? CH3CO OCH3. Here also oxygen lone pair is providing the plus R to the carbonyl carbon. That's why new electrophilic character also will be less. But the plus R effect of nitrogen is greater than the plus R effect of the oxygen, because nitrogen electronegativity is less. Releasing capacity of electron will be more. So that's why this CH3CO NH2 is a less will be less attacked by the nucleophile H2O, but whereas CH3CO OCH3 will be more attacked by the H2O compared to CH3CO NH2. And option D, that is acid anhydride. Acid anhydride also is carbonyl carbon is there both side, and that also will be reduced due to plus R, but one lone pair is giving both the sides CO. That's why overall effective plus R will be less compared to the ester. The reactivity order always during nucleophilic additions, acid chloride is greater than, acid anhydride is greater than, ester is greater than amide. So that's why acid chloride only, chlorine is with giving the withdrawing effect. So that's why that will undergo faster hydrolysis. Hydrolysis means the entire mechanism what I show you. And now that will form acid, and then your answer will be nothing but which options will be your answer, my dear? Your answer will be nothing but this acid chloride will be your answer, which will undergo faster hydrolysis. If among all those three order, if I say, your order will be A, acid chloride will be faster. After that, which one will be there? After that, option D will be there. Then after that, which one will be there? C. And the least will be there, B. These will be the order of hydrolysis. But in these questions, they are asking which of the following molecules hydrolyze fast. That's why single correct means first options will be your answers. What about the second question they ask? Which does not follow the general trends among the halogens? Electron affinity, everybody knows. Generally down the group, electronegativity and electron affinity has to be decreases. But here chlorine has a more electron affinity than fluorine based on the size. You know very well. Chlorine electron affinity is greater than fluorine, because whenever chlorine is taking one electron converting to Cl minus, the amount of energy released when 1 mole of chlorine atom is gaining 1 mole of electron converted to 1 mole of Cl minus, the amount of energy release is nothing but a electron affinity or electron gain enthalpy. Now this value is, suppose if it is a X, minus X, release is there, that's why minus sign. Whereas fluorine, when taking one electron, is converting to F minus, delta H is nothing but a minus Y. Now my question is X greater than Y. Why? Chlorine size is more. But that's why by gaining of one electron when it is converting to Cl minus, because of the bigger size, dispersion of charge will be more, stability will be more. Due to more stability of Cl minus compared to F minus, release of energy will be more. That's why electron affinity of chlorine is greater than fluorine. But as per the logical sense, it should be fluorine is greater than chlorine, but originally it was observed chlorine is greater than fluorine due to the size effect. That's why that electron affinity is not following the general trends. That's what the questions were asked over here. Now, third questions regarding the basicity. This question based on organic as well as amine chapter as well as GOC, both we can correct. Now, as far as basicity is concerned, after the basicity is related to that two factor, donation tendency of electron to the H plus, and after donation whatever the conjugate acid will be there, stability of that one. Now we know very well whenever methyl group is there. Now if you look at, always secondary amine will be more basic compared to primary and tertiary. But the question is, in case of a methyl group, if it is there, then 1 degree is more basic compared to 3 degree amine. This is your 2 degree amine. 2 degree amine, this is your 1 degree amine, this is your 3 degree amine. So now, what is the degree of amine? Degree of the nitrogen is a degree of the amine. That if it is a NH2 is there, with that alkyl group is there, that is a primary amine. If only NH group is there, secondary amine. Only N is there, 3 degree amine. So that's why degree of the nitrogen is a degree of the amine. You look at NH2 is there, 1 degree amine. NH is there, 2 degree amine, N is there 3 degree amine. So that's why that basicity order is 2 degree amine greater than 1 degree and 3 degree, and in between 1 degree 3 degree, if methyl is there 1 degree is greater than 3 degree, if ethyl is there 3 degree is greater than 1 degree. That's why second options will be the answer. And why these things is happening, there are two factors I am explaining. After donation, if you look at this secondary amine, why secondary amine is more basic? After donation to the electron to the H plus, it will form what? CH3 whole 2 NH2 plus, NH2 plus. Now these will undergo stability via hydration like a water molecule. Now this hydration energy as well as donation, these two power, that means the stability of the conjugate acid after gaining of the H plus is called as a conjugate acid, and donation, both factor are optimized in case of a 2 degree amine, whereas 3 degree amine availability of lone pair over the nitrogen is maximum, donation power is maximum, but hydration of the conjugate acid by water will be what? Least for 3 degree amine, and 1 degree amine hydration after donation the stability of conjugate acid via hydration is a maximum, but donation tendency will be least, but these two factors is optimized in a 2 degree amine. That's why 2 degree amine is greater than the 1 and 3 degree, but based on the which alkyl group, either 1 degree is greater than 3 degree or 3 degree will be greater than 1 degree. If methyl is there, 1 degree is greater than 3 degree. That's why second options will be your answers. Now let us the next questions. In next questions, what they ask? They ask vapor pressure. Here question number is 5. Vapor pressure of a pure liquid A is 200 millimeter of mercury. If 1 mole of A and 3 moles of B are mixed, assuming the solution behave like a ideal, find the vapor pressure of pure liquid of B if total pressure of the solution is 500 millimeter of mercury. It's based on the Raoult's law. So then pressure, total pressure will be equals to, if you look at the total pressure will be equals to what will be there? The total pressure will be equals to PA, the liquid A plus liquid B into the mixture. Again PA will be equals to PA naught into mole fraction of A plus PB naught into mole fraction of B. Now if you look at mole fraction is nothing but a total number of moles of the component with respect to the number of moles of the component with respect to the total number of moles. So now mole fraction of A will be equals to number of moles of A into the mixture 1 by total mole of A plus mole of B, which is nothing but a 1 plus 3, which is nothing but a 4. Mole fraction of B will be equals to 3 by 4. So now P total, they told P total is 500 will be equals to PA naught, they are telling, assuming ideal, the vapor pressure of pure liquid B they are asking, and vapor pressure of pure liquid A they told 200 into mole fraction of A 1 by 4 plus PB naught they are asking into mole fraction of B, which is 3 by 4. Now you look at 200 into 1 by 4, which is 50, then 500 minus 50 will be equals to PB naught into 3 by 4. 500 minus 50 is 450 into 4 divided by 3 equals to PB naught. Now 3 15 jar this. Now if you look at over here, 150 into 4, which is 600, PB naught will be equals to coming 600. If you look at the options, they are providing the options. A is 500, B is 200, C is 700, D is 600. That's why which options will be the answer? 600 we got. You look at PB naught. Is it clear or not? Now, sixth question is very nice question, 6th, 7th questions. Metallic nature of aluminium is less than the gallium. Metallic character generally down the group used to increase. Boron, aluminium, gallium, indium, thallium. But the question is, if you look at, it's a group 13 questions. Generally, due to core electronic structure are different, here there are different characteristics will be appear. Even if you look at the electronegativity value and electron positivity, aluminium is more than the gallium. They are telling metallic nature of aluminium is less. Aluminium is more metallic, more tendency to lose the electron compared to gallium. Now the question is, ionic radius of aluminium plus 3 is less than the gallium. Gallium is a smaller size, not they are telling aluminium is less than gallium. Gallium is less than aluminium. Why? Because the idea is like that, you know very well. Idea is like that. If you look at boron, aluminium, gallium. Now boron will be there. Here helium code and 2s2, 2p1. Where aluminium, neon code 3s2, 3p1. Whereas gallium is argon code 3d10, 4s2, 4p1. Like that. Due to this d electron which has a poor shielding, due to this poor shielding, nucleus will be more powerful, and because of that it will attract the valence electron more powerful way, then there will be a contraction in size. That's why gallium is lesser size, as well as the tendency to lose the electron, electropositivity, which is nothing but a metallic character. Gallium is less, aluminium is higher. So that's why both the statements are incorrect. That's why which options will be your answer? First options will be your answers. Now, seventh questions. Pairing energy is greater than the crystal field in octahedral field CFSE. These things is nothing but your what? CFSE add octahedral field. CFSE add octahedral. If it is pairing energy is greater compared to the CFSE, high spin complex. Naturally, if pairing energy is higher, there will be no pairing. I hope you know 5 sets of d orbital in octahedral field, they will be split like this way, and this is your Barry center, and this is nothing but your this entire difference is delta naught, and now this is minus 2 by 5 delta naught, and per electron here you will get plus 3 by 5 delta naught per electron. All those points you know. So now the idea is, if you look at, if the crystal field, if strong field ligand is there, splitting will be more. If splitting is more, then CFSE will be more. Then against the Hund's rule, pairing will be taking place. So Hund's rule is to say, first that electron will fill it up 1 1 1, and then only pairing. But here already the electron, the orbital energy will not be equal, they will split. And moreover, first this is called as you know very well, this is T2G and this is your EG. First, if there is a strong field ligand is there, first T2G level will be filled up, and then there will be pairing will be there in T2G level. So that's why there will be low spin complex, as because of unpaired electron will be less. But the question is, if pairing energy is high, that means due to pairing, whenever pairing energy higher than the CFSE, if CFSE is high, which will compensate the pairing energy. Pairing energy is the destabilization energy due to the pairing of electron into that T2G level or EG level, and this pairing is a destabilization. But if crystal field stabilization energy is more, if splitting is more, CFSE will be more. If CFSE is more, CFSE, if it is a more, it will overcome the pairing energy, destabilization energy due to pairing of electron, that energy will be less. That's why what will happen, due to if CFSE is high, due to pairing, whatever the destabilization energy will be there, that will be overcome by the CFSE. So that's why in that case pairing will be taking place if the CFSE is more. But if CFSE is less than the pairing energy, then what will happen? Then there will be no pairing, electron will fill it up 1 1 1. That's why tendency to get the unpaired electron will be more, then high spin complex tendency will be more. That's why statement 1 is correct. But in tetrahedral, low spin complex are rare because pairing energy is high. Pairing energy high means always there will be tendency, first electron will fill it up 1 1 1. That's why there is a high spin complex chance will be there, because in tetrahedral complex, reverse situation. This is your octahedral. Tetrahedral will be what? Reverse situation, like this situation. Here this will be your T2G and here this will be your EG, like that situation. So energy wise, that's why the tendency to form a low spin complex is very less in tetrahedral complex, because pairing energy will be high and CFAC will less compared to the octahedral. And square planar complex, CFAC order always you remember, CFAC will be always square planar is greater than octahedral is greater than tetrahedral. So that is why that tetrahedral complex CFAC is less. As CFAC is less, it cannot overcome the pairing energy. That's why they are written over here in tetrahedral low spin complex are rare. Low spin means I get to have a pairing. Pairing means my unpaired electron will be less. But as CFAC is least in tetrahedral complexes, that's why pairing energy cannot be overcome by the CFAC. So that's why pairing energy is greater than delta naught. They are telling delta naught is a energy level between energy difference between T2G and EG after splitting of d orbital. I hope this concept give you clarity. So now if you look at the next level of questions, what they are asking. So now next level up, that's why if you look at previous questions, what we discussed, we discussed, they are giving which will be the correct answer. Both statement is, they are telling first option, both statement 1 and statement 2 are incorrect. Statement 1 incorrect, statement 2 correct. Both statement are correct. Yes, both the statement are correct. Option C will be your answer. Both the statement is correct. So now we are moving to the next questions. In next questions they are asking, the weight of 0.1 mole of the above compound is x into 10 power of 3. Find the value of x. It's very simple. Only you add a molar mass, you find out. Molar mass means 1 mole of substance and 0.1 mole means whatever the molar mass is coming divided by 10. And you have to take in that form, you will get your answers. Now here they are telling ninth questions, 100 gram of calcium carbonate when reacted with a 0.1 mole of HCl, then the moles of calcium chloride is P into 10 power of minus 3. Find out the P. Now calcium carbonate, when it will be react with a HCl, then what it will form? Calcium chloride, and 1 mole of calcium carbonate has to react with a 2 mole of HCl, then 1 mole of calcium chloride, and with that H2CO3 means H2O plus CO2 used to form. Carbonic acid always will be dissociated into in the form of H2 and CO2. That means for 1 mole of calcium carbonate I need a 2 mole of HCl. Now that mole ratio they will react. Stoichiometric coefficient 1 and 2. Now you look at, they are telling 100 gram. 100 gram means what number of moles of calcium carbonate given by molar mass. Molar mass of calcium carbonate also 100. Why? Because calcium 40, carbonate 60, 40 plus 60 is 100. That's why 1 mole of calcium carbonate reacted with a 0.1 mole of HCl. This is their 1 mole. This is 0.19 mole. That means whatever mole reacted HCl, half amount of this. Obviously you can look at very clearly, HCl is a limiting reagent. So that's why whatever mole of HCl reacted, that half amount of calcium carbonate mole will be reacted. It is fully reacted 0.1 and then immediately here reacted nothing but a 0.19 by 2. That much mole reacted. So now here 2 means here 1, here 0.1 means here 0.19 and this much will be leftover portion. Now whatever calcium carbonate, calcium chloride will be formed, whatever the HCl react, half amount of moles of calcium chloride is to form, or whatever the calcium carbonate react this much, that mole amount of calcium chloride used to form. Then calcium chloride used to form 0.19 by 2. This many mole of calcium chloride is to form. Now they are telling the number of moles of calcium chloride formed, they are asking is nothing but a P into 10 power of minus 3. Now if you look at, if I convert in terms of these things, this is 10. So 0.9 is nothing but a 0.95. 19 by 2 is nothing but a 0.95. 0.95 0.95, 0.95 and this divided by 10, which is 0. Because 19 by 2 is a 0.95 and here 10 is there. So now these things is equals to, I can write down 95 into 10 power of minus 3. I have to take in this form. So that's why how many moles of calcium chloride for 0.19 by 2? That many moles. And I have to take in this form. This thing 0.19 by 2 is nothing but your 0.95. This 0 if you look at here what I did, 19 means 9.5. Yes or no? 19 means 9.5, but here already I took it, this factor I took it over here. Simple idea, you look at these things is nothing but a 0.1 by 2 na. So then here these things will be already 100 will come. So 0.19 means 2 into 100. 19 by 2 is nothing but a 9.5. Then 9 this will be your 9.5 by 100. Now these things is there, then if this decimal point you remove, another 0 will come over here, which is nothing but a 95 into 10 power of minus 3. So that's why they are taking in the form of p into 10 power of minus 3, which is p value they are asking. P value will be nothing but your 95. That will be your answers. Is it clear or not? I hope by solving these things I am able to give clarity. To get more this type of videos and question answer discussions, please come, comments and confident for your upcoming exam. Even the incoming seniors who are planning for next year for the JEE exam, have a look of PYQ discussions. You will get the full depth, clarity and confidence. Thank you very much. Thank you very much, my dear student. Thank you all.